Okay, now welcome to a meeting. Basically, it's not a lecture, it's a meeting devoted to design science research processes and activities. So what I will be doing, I have some slides that I will show, but they are not very interesting. What I will be doing is telling you some stories. And the stories is about my personal experience of design science research. So why it's interesting to listen to such stories is because if you take any paper which present design science research result, you will never know how they discovered what they write about, because you may know what was their knowledge base with which they started. You may know the result, what is an artifact, how it looked like. You may know how they tried this artifact in some real case and what were the result, but not how it's actually was discovered. This is quite usual, and you know the results and do not know the creative processes, and these processes are revealed normally in public lectures of some high-level researcher getting a high-level prize. There is a Nobel lecture of famous physician Richard Feynman. It's very interesting. He described how he get to his results, and it was not straightforward. Another example is Turing lecture. He described how the design PDP operational system, also very interesting. I'm not about to get any high-level prize, so I will tell some stories to you. Okay, so I will start sharing some slides. So you will tell me if you see it or not. So first I will share my PowerPoint, and then I will try to press F5 on it. We'll see. Do you see the screen?
Yes, we see.
Yeah.
Yes.
Oh, okay, good. I hope it's recording both the screen and me somewhere. Do you see me talking?
Yes, in small window.
Yeah. Okay. I hope you will see it in recording as well. I tried it and it was there. So the lecture, or rather a meeting, is devoted to activities and processes. And I hope that you have looked through the first two lectures where you were presented with more or less two different tools that can help in activities and processes. One is a canonic process in design science, which goes from explicate problem, define requirements, design artifact, demonstrate and evaluate. And there are some methods that are used in each thing, in each block, and some knowledge base is also used in it. And it looks like straightforward, but it's normally it doesn't go in this way. So I will show and explain why. And the second one is Canvas, which has several so-called talking points, which in a way represent what is in the process. You need to describe practice, you need to describe problem, artifact, and basically then you can describe knowledge base, what was used in developing it, and requirements, and even a process. But it doesn't follow in a way that there is a sequence, and it means that if you use this canvas, you can start in any block. You can start with defining artifact without having any problem or any requirements. And this happens, so that's okay. So the sequence is removed, and in a way it's a good thing. Now I will go to describe you some examples of DCR processes from my experience. And first, before that, I will just make a point that the process is trying to present design science research as using a number of methods. When you take a knowledge base, apply these methods, and create something new. And this point of view that you can create something new from something that is known is a speculative one. Basically, it's normally it's not true. And there is a book of Michael Polanyi. I don't know if you have heard his name. At least if you had a course in knowledge management, you should know who he is. And he has a book, The Tacit Dimension. Tacit, it means that it's something that happens in the brain without explication. It's silent knowledge that is used in a way without any logical process. And human brains have a capacity to create a holistic view from different signals coming to the world, to the eye or to ears, and to create a view that doesn't exist in each of them. And this is a variant when you get a 3D picture, when you have two pictures with 2D dimension. This is what's happening in human brain, and human brain are capable to creating something completely new that does not exist or could not be derived from the knowledge that already exists. And why it's very important for design science research in comparison with normal research or empirically based research is a table which described what is the difference. And the difference is the timeline, empirical research trying to understand what is now or what was in the past. This year is directed for the future, which doesn't exist yet. And the idea with empirical based research is to explain how the world works. And design science suggests a new world. You need to imagine the new world which doesn't exist. And there is a different process in empirical research. You need to establish facts and develop theories that explain them. And in design science research, you need to generate hypotheses and then see whether it works or not. And it's different what how it is used, especially in IT. Empirical research follows practice and explain it, and DCR is aimed to lead the practice. Whether it's lead or not, it's another matter. Okay, so even if normal research, you need to have a creative power and discovery, and this year, which is directed to something completely new, you need to have imagination. So it's even more, you need to have some creative power to create it. Just one comment, there is no real border between empirical research and design science research, because when empirical research is completed and new knowledge is obtained, it can be used as an artifact for creating a new world. And if you take Newton's laws, especially gravitation, then in the beginning it's just explained how the planets goes according to the orbits, but later it was used for defining for creating new machinery. So new knowledge often can come back, re-entry the world, and become a useful artifact that changes the world. And if you take something less drastic, like software, empirical research, in software, there is a law that says if the project is late, adding new people to the project will make it even more late. And it's re-enters in the practice in the way that...
How do I change those?
Excuse me?
These notifications, where are they?
Can you say it louder? Okay, so people are using this law, which empirical law, and trying to avoid adding more people to the project if there is a chance it will be late. So the law as empirical law defined based on analyzing a lot of practices, re-enter as a useful artifacts to affect these practices, to prevent it. Okay, so...
can I ask you one thing?
Yeah, sure.
Can artifacts be only objects, or can it be something like an idea?
Yeah, artifact is something that you can use in practice. For example, if you define a new method of developing IT system, it will be an artifact. I think in one of the lectures, Paul in slides have some taxonomies of artifact. So it can be an IT systems. In the discipline where we are, it's normally it's not a solid object. It can be an IT system, but it can be a modeling tool that helps to define the problems or design solutions as a main component of artifacts. It's very seldom it's an object in our discipline. So yes, it's an idea that can be used. So it should have some direction for applying it. We'll go in the detail a bit later with it.
Okay. Semantically, it's man-made.
Yeah. Yes, it's man-made. Yeah, it's from the brain. Okay, so we go to the first example, and it's called simulated apprenticeship. And I took this example because simulated apprenticeship is used in this course and in other course at DSV, especially in if you take master programs, it's especially in YGov program. So this example is more like will appeal to you. So how it was developed? It was developed from the problem, and the problem was generic. So how to acquire modeling skills in a university classroom, because the idea came to me when I started teaching, and we have a lot of courses that concern modeling. It could be conceptual modeling for creating databases, could be business process modeling, enterprise modeling, and so on. And the main teaching method was based on having a project where students get an assignment and model something. It could be a system, it could be a company, or it could be something else. So, and this assignment was textual. So you get a text that describes a case, and you model this case. I thought there is a problem in it, because if you go to practice and you need to model, you will never get this text. So the text doesn't exist. There is only practice, people, they are doing something. You can have some systems employed, physical or IT system, you can have documentation and so on. Basically, from what we teach in class, you really don't know how to model when you come to practice. And this is because there are two parts in modeling. One is formal. You have different notation how you depict a model. So there is a system, semantic, and rules. And there are 10 rules how you translate from one notation to another. And basically, if you have a text which explicates the situation, you translate a model built in this text to a formal model in some notation. You are not building a model from scratch. And informal part, how to capture the reality, how to talk to people, how to observe what they are doing, ask questions. This were not taught at all. And I thought this was a problem and we need to deal with that. What is a normal solution? Normal solution actually comes after graduation. You are going to some company and you might be assigned as an assistant to a more experienced modeler. You go with him, do some parts of work and so on. And this is normal apprenticeship, which is known from far back to in history. So apprenticeship is a good thing when you need to get tacit knowledge on how to do things. No formalities, but how to do it in reality. But in university, we have a problem. The classes are big. For example, now we have 81 participants. So we cannot assign to each small group somebody whom they follow. And the basic idea was, okay, we need some kind of simulation to do the job. And we started a project which was we've got a bit of resources from our faculty to work on it. We applied for resources and we got them. And okay, simulation is simulation, what to simulate. And I started to build so-called knowledge base, looking for simulation. And I was looking at simulation of a business case, and I found some literature that tried to simulate a company. So you can go around in the computer and see who is working in the company and even talk to them and so on. Simulation of a patient in a hospital when the patient can give some complaint and you need to diagnose what's the matter with him and so on. And I started to look to some kind of software to build this simulation. And it was not easy, and we didn't have anybody proficient in 3D simulation to build such a model. At the same time, we had decided to test a new method on a course. We were the first year bachelor course, introductory course, which has a lot of modeling in it. And there were a project with text already there that was run in the past, and we needed to do it in a different way. And so while I was looking how to simulate a company, another member of our team, Stuart Kowalski, just said, okay, we are going to record some interviews with stakeholders. And what we did, we did it with ourselves. We assigned you will be a consultant and you will be a sales manager at the company, which is a business case. And we created a dialogue in which it was revealed how the process of selling is going in the company. And we did it for with other stakeholders. We simulated some other topics. So we get 3 simulated interviews with stakeholders, but still there was a lot of different information in the text, which was not captured in the stakeholders. And so what to do? And when I got this interviews record, I started to think how we can fill the rest of information, translate from text to something that is not text. And I started to think, okay, we need information about a company, how many people, which department, and so on. Okay, then I create a website for this company. So I have some questions, I think. It was too fast. Okay. Chat. Okay, Krister, what do you mean to change to myself? Oh. So view. I'm trying to. Okay, I'm not sure that I can do it, Krister. You want me to exchange myself to. No. Okay, I don't know how to do it. I will see. Remote control. Video setting. Okay, Krister, I'm sorry, I don't know how to switch. Sorry for. Okay, I will continue. Okay, this was one thing, to create a site where I can describe the company, what is their business idea, what they sell, and so on. Then the next thing was how to describe what IT systems they are using. So they were using some things with just Excel sheets and some real systems. So I went and find real systems and make a links, say we are using this and this systems. And I created Excel sheets to show that they are using Excel sheets in sales process. And then we needed information about their finances. And I simulated information that normally is shown in Swedish websites that can show any company. How much they earn for the last 3 years, how many people they have, and so on. And the same was with feedback from their customers. I simulated tweets about the company. And suddenly there were nothing left from the text. The text disappeared and appeared a number of different sources, interviews, websites, linked to real websites, some kind of documents, and they described the case. And the text disappeared, and students should work with this information. So I am going to the next slide, and it shows the main idea. So the text disappearing, and we have videos, links, HTML file, and anything else. So it's multimedia presentation. And we put it in work, and we evaluated what the students feel. Do they like it or not? Do they feel they better understand their future profession, and so on? And the same with the teachers. And basically we then generalize it as a method how to create a case. And it was elaborated, and with different versions. One version is to have everything artificial, like we did in the first case, or half artificial, like in the case you have, where real people is combined with fictional websites and other fictional things. And this is a method which was in the end called apprenticeship simulated apprenticeship. It wasn't called this in the beginning. It means that we moved from simulating a business case, a company, to simulating a situation of apprenticeship. In what way? In a way that looking through the sources and interviews, it's basically what an expert does. And then an expert can ask an apprentice to do a factual job to look through these sources and create some model. So that's why it's called simulated apprenticeship. So what I want to do now is just to stop share. You can ask questions, and I will show the site for your project, which follows this idea of simulated apprenticeship. So I am stopping sharing. Is there any questions? Hello?
Will this presentation be available for download?
Excuse me?
Will this presentation be available for download?
I am recording it. I hope that we'll get a good recording. I will upload slides, but slides doesn't show much. So without video that we hopefully get, you can't get much from the slides. Okay? Okay. So now I will share my browser and show yes chat. Yes, you are free to. You mean in your course you are free to choose any tool that you want in your process. In other courses, we say that you model with this, this, and this. But here it's up to you what you use. You just need to create a solution that hopefully solves the problem. Okay, so I am sharing a screen and sharing this one. And this is Harmony Online Consultation Process project, and this is a project that you will be doing in this course. So this is a bit of, no, this is not the right
Excuse
one.
me.
Yes?
Is it the same project as we had in Systoid course?
It's the same business case, but you will not be doing the same thing.
Okay.
Yeah. This is the wrong case. I need to find the right one. So what I do to ST Transformer, which is consulting company. So I show it, and it has a number of projects. And this is, I think, the solution development project, which we have. And I go to its websites. So this
People
is it.
are unmuted. They should mute themselves.
Excuse me?
Alex and Krista are unmuted. I think we hear the background noise of them.
Oh, okay. So this is the right size. There is a description of your project. So this is general things, and we have 3 different versions of the project. They are in iLearn, and we have project assignments. They are listed in iLearn. Sometimes they are here, and we have resources. And here we have just 2 types of resources: interviews and internet resources. And internet resources described 2 partners in the case. You are part of ST Transformer, and there is a customer Harmony inside, and we can have a look what they are doing. It's dietitians which treat IBS syndrome, and this is a syndrome which normal medicines doesn't cover. So they treat it in different ways. And we also have some links to show you what you need to look for. For example, what is IBS? And this is to Wikipedia, or who are competitors to this company. But you can find more of it. So this are resources which your master defined, and the most interesting resources, basically you need to find yourself, because you need to go and look for IBS, food map, and other things that concern this type of syndrome. And we have interviews, and if you click, you see. I don't know if you hear it or not, but it doesn't matter.
And our specialty, balloons.
Yeah, and it's a disease that are
So, and we have.
recognized. So
we have 1, 2, 3, 4, 5, 6 different pieces, so divided in different topics, and you pick those topics that you need for your design. Other topics are more about the context of the design. So this is what you will be working. This is a case which should inspire your work, but you need to think that your artifact should be more generic than is needed for this particular company, because design science is directed for creating generic artifacts that can be used in many situations, and not just one specific artifact. So this is an example of a company that needs a solution, but this is not the only company that needs a solution. Other companies should be able, similar or not similar companies should be able to use the same solution. So I am stopping sharing this one. And if there are questions, please ask. Otherwise, I go back to my slides. Okay.
Use your headset, please.
Yeah. Okay. I will continue, right?
I got a question.
Yes.
To find harmony, do I have to go into systems to find the harmony? Do you have a link put up somewhere in the?
Just a moment. I think I will show you in I Learn. I go back to this. Need to go.
I'm sorry for my noise. I started another computer because the microphone didn't work in the first one, so I had to start another computer.
I will try here. I will go to I Learn. I Learn 2 and show where you can find. Okay, this is a project. So we have a project here. I explained it, and here we have project site.
Okay.
And you go directly to the right site. So you don't need to go to ST transform and then find your project.
Okay.
So all information is here, and here you have project assignments. We'll go through it tomorrow, basically, in details. I just showed it to show an example of simulated apprenticeship in use. Okay, so I will go back to this one. Do you see it? Right?
Yes.
Do you see the slides?
Yes, I see the slide, yeah.
Yes, we can.
Yeah, okay, so I'll continue. And the other thing that we did with simulated apprenticeship, in the beginning, it was used separately for different courses, but then we decided to use it for another problem. And this problem is the problem of fragmented knowledge again in university teaching, and it means that you have a number of courses. They're often not connected to each other in any logical way, and it's different to understand how the whole discipline look like, because you have fragments of different things. And there are different causes for this, but it doesn't matter. And there are different solutions. One of them to have a special integration course, but the problem is that it comes at the end of the program, and during the whole program you have fragmentation. So what we decided to try, and we used and even evaluated a bit, take the same basic case and fit it in different courses. And this was done with Harmony Inside. After we created it, it looked like it's rather universal. You have a company and it has some problems, and you can model this, you can model that, and you can devise different things for it. And this is the fourth course in which it is used. And we discussed with several students that went through at least 2 courses with this case, and all of them said that it helped to get connection between 2 courses, better understand connection, but they couldn't explain how. And it just confirmed our hypothesis that connection should be made on a tacit level. So you look on the same object, the company, Harmony Inside, and their problem from different perspective in different courses, and it can help to create a holistic picture in the same thing as here. So you get more dimensions than what you get for each course. And it means that when artifact was created, it was created for a special problem. It helped to resolve the problem, at least partially, but the usage of it could be bigger. So you can find another problem that could be solved with the same artifact if you adjust its usage in a different way. So what we have learned from here is that the development was not straightforward. An attempt of developing it top down, we have a problem, we decide we need the simulation, and then we continue, didn't work. We switched to working with a special case. And a lot of ad hoc decisions were made just because we started with recordings, and the question is what to do to connect them to all other information. And then come ad hoc decision, which were then analyzed, summarized, and we created a concept of simulated apprenticeship, which can be used in many courses. So we get back to defining a generic solution through getting a specific solution for a specific course at a specific time. And this is not presented in standard processes, so we need to be able to think about DCR process in another way. And this is a picture from one of the recommended work, which considers that design science research happened in 2 worlds. One world is a concrete physical world in which we live. And this is represented here. So we have a situation, a company with some problems. And problems is that something is not desirable in this situation, and we want to remove it's not desirable. It doesn't mean that it's really a problem. It can be a challenge. We want to earn more, and we can formulate it. We think we don't earn as much as we can. So this can be set as a problem, but it may be just a desire. So we need to move to another situation where this problem doesn't exist. So basically another situation is a solution. And in this situation, we have test case. We move from here, and we need to evaluate whether problem disappears or not, or it became worse or became less, and also whether there is any additional problems that we've got that we didn't have. So if we solve one problem but get a bunch of new problems, it's not a good solution. But this is in a real world, and for us in the example that I described, the real world was a particular course. And we evaluated the solution, and according to evaluation, it solves the problem at least at a certain extent. But to be a science, we need some generic artifact. And in our case, it was how to employ this thing that we created in any course at our university or any other university. So we generalize situations that there is a course which has modeling, some kind of modeling, not a particular course. The problem is from the beginning generic, how to teach students to get information to build this model. And a solution was basically an instruction how you can create a case with a lot of variants, and even how you can create with WordPress, how you create a site which can be used. So, and it was a generic solution. And if we look how we worked in this process, we started here. We started with generic problem and generic situation, because we didn't want just to solve the problem with specific course. The course was chosen later as a test case. We could have chosen any other case as well. So we started here, and we tried to create a generic thing like simulating a business case. We failed and went here and basically built a half ad hoc solution here that works. And then we get back and generalize it. Okay, now we know how to build simulated apprenticeship for any course with modeling. And we tested it in several other courses. We extended the problem from just acquiring modeling skills to avoiding fragmentation, and tried it for a different problem. And it means that when an artifact exists, we can try apply it to a different problem. So we all the time are going between two things. We are not top down, and it means that basically you can try to build everything here and then apply it. It will be a pure demonstration. But it's very seldom you can do it. You need a case, and you need to test things. You cannot test things in generic way. You always need to apply. And if you are interested, you can read a paper which describes this idea. So try to formalize. Here it's a hypothesis called that going from generic situation with generic problem to another situation, a hypothesis, there won't be a problem, this problem, and there won't be this undesirable new problems. And here we can apply it to a specific one. So this is how in reality a process goes. But when we write a paper, we describe the generic solution and we describe a test case. So we describe separately this thing and separately this thing. So no process actually is described in the paper. We have a number of papers on this topic, but none of them describe it. Okay, so this is the way how things are going, or how we can represent a process when we design an artifact or a generic solution. So this is an example of how the process can go and which methods from standard empirical research you can use. And it's called generic innovation. It starts with concrete situation with a problem that needed solution. So this is, we are somewhere here. We looked at situation and defined here is a problem, we want to solve it, but we don't want to solve it in a specific way, we want to solve it generally. So we need generalized situation. We can look at literature, for example, to find out that this problem exists in other organizations. Or we can look at other organizations, we can have a kind of survey to get that, okay, this problem is not specific for this organization. It's in general way, it comes quite often. Then we design a solution, generic, which we didn't in the case I described. We used what we found in literature, combine it, maybe we make empirical study of best practices and generalize it. Then we implement it in a specific situation. And this is a problem on its own, how to do it. And then we evaluated whether the problem in this situation was found. And it's empirical study. You can interview people, what they think. Is it better? Is it worse? What has been changed and why it's better and so on. And our case we can describe in the same way, but it's not this one because we started with generic situation, get back to specific situation, solve the problem, get back to define the generic solution. But we made evaluation with several surveys on the way in different courses. Okay, so you because I hope most of you have gone through previous course which describe you a number of methods related to empirical studies, and they are useful in design science as well. So, and in reading literature, we have a short paper that describes this kind of things. Okay, we go back and I will just describe another example to show how the process can go. And this is an example which resulted in creating a special modeling technique, which is called Fractal Enterprise Model. And it has two elements. One is we call the process. It can be very high level of process. Develop a new kind of business information system for customers. And they have assets. Assets is something that you need to be able to run this process continuously, to have many instances of many new information systems developed for customer. And for this, you need customers as beneficiary code. You need orders from these customers. You need software developers. And you need different kind of tools to be able to create a new systems. And okay, we have assets where we can get them. And to have these assets, we need three kind of processes. One is called acquire, there is a maintain process, and there is a retire process. So we need to manage each asset, and for this we need other processes. And these other processes also require assets, like you need sales staff for sales. And sales, we need to acquire both customers and new orders from customers that exist or from customers that are new as well. And in this way, we can go down and find how actually the company works. What is the history behind it? The history behind it that when I was, this picture is a picture how my company started in 1989, sorry. I'm not that old. We were doing business process modeling for different customers, and we discovered a problem that when you come to a new place, how do I know which processes do they have to suggest how to model them? And it was quite difficult. And this was created just to find out what processes existed. So the idea was, okay, this is a primary process. You have a customer, somebody who pays, or somebody pays on behalf of this beneficiary. For example, DSV is paid by state for teaching you, but you are a beneficiary basically. State benefits only indirectly. So this kind of processes is easy to discover because you can ask what customers you have, what do they do for this customer, and so on. And you get the upper level, but what about the rest? And this was created to get down to these processes. But basically, when it was created, it shows much more than which process exists. It shows basically how the whole company works. And the artifact was much more than solution of this problem, and we started to look for what it can be used. And we are still looking, and we have tested different things, and some of them successfully. And this means that in the terms of this picture, here if we talk about simulation, apprenticeship simulation, we extended the problem, but in case of fractal enterprise model, we completely changed the problem. So we are looking how to use this modeling for business model innovation and for strategic decisions and so on. So much more than finding all the processes. Actually, it was never used to finding the processes. And it means when you create artifact, it might or might not solve the problem which you started with, but it may show that this artifact can be used for something completely different. And even if it was not successful for solving the initial problem, it can be successful for something else. So it's worth, after artifacts exist, to look for what it can be used after. So it means that this process actually doesn't really work. You can start here and then find the problem. Okay, these were stories, or it's end of stories. Do you have any questions on the stories? Okay, doesn't.
Is there
Yes?
any reason why you have blue arrows and why you have black arrows in this picture?
In this picture?
Yes.
Yeah, okay. It's like this is internal. It's about the company itself, what it has. But to get this assets filled in, you need to use external pools. So basically, to get a customer here, you need to draw it from this pool. Companies that need information system. It's a market, and you draw and try to create a customer. So somebody from here becomes your customer. And this is an internal agent, which can also draw a system development company, which is our competitor can draw. We have a competitor on this pool. And it can be vice versa. There is, for example, we need software developers. We need a pool of software developers that are looking for a job. And there is an external agent, for example, DSV, that fills the pool. So all these blue arrows concern connection to external elements. These are external elements. Yeah, it's not mandatory they are blue, but just to differentiate. They have a dot to show, and they are going from a different elements than internal elements. These two are internal.
Wow, thank you. Thank you.
Yeah.
Some arrows are dotted and some are.
Yeah, it's like these arrows is assets that are used in these processes. They are not dotted, and this is assets. This is process that manage these assets.
Once again?
This is a process which manage this asset. It's acquiring new software developers. They are dashed. So this is a different relation. This relation is this, this asset is used in this process. And dashed, it means that this process manages this asset, do something with this asset. Okay. So it's just to show more, in more explicit ways, that there are two relationships between assets and process. One is used in, and another is managed by. Okay. Okay, and this is connection to external. So it's a different kind of relationship. Draw from and fill in. Okay, so so if you are interested, I can get the literature on it, and at least in one course in EAGov program, there will be some introduction to this this model. Okay, then we go and have a look on design science canvas, which is quite useful. You can use it, and we recommend you use it. And there is a practice. You need to describe generic practice. Basically, it corresponds your movement in generic space of possible problem, situations, and solution. So here it's a generic problem that concern generic practice, for example, teaching or teaching specific modeling. You have an artifact, what you do, what it consists of, and you have you can define requirements on artifact. And what requirements does, it's basically you try to make the space where you look for solution a bit smaller. For example, if we take simulated apprenticeship, one of implicit requirements, it wasn't formulated until late, was basically it should be affordable for a normal institution. And basically the first direction to create simulation of a company was quite expensive. And we discovered that cases when it is used was connected to a book which was sold in quite large quantities and was a companion to the book. And we have courses we couldn't spend this much for each case. And this requirements was basically not difficult to satisfy with simulated apprenticeship. We calculated all time and it was quite affordable for anybody to put in. We had professional studio, but it's not mandatory. You can have a normal camera and record interviews, so no problems. So you can think about that you shouldn't try to create something expensive if you know that in situation which it will be installed, they don't have this amount of money to do something. So you will be creating a solution which not be affordable to them. So requirements is to narrow down the search for a solution. Quality and effects, it's what you get and basically trying to avoid that you get side effects, negative side effects. Positive side effects you can get, and that was good because, for example, in simulated apprenticeship, one student gave feedback that he had what's called, when it's difficult to read, there's a syndrome when you can't read text. And he said,
dyslexia.
Yeah, dyslexia. And he said, it was very good for me to have interviews recorded. Then I didn't need to read. So, and this was a side effect, basically positive side effect. It was side effects that are really not negative because students said that it's more challenging and take more times to get through apprenticeship simulations than if you have a text, but it wasn't it was not negative feeling, but it's a side effect that it requires more time for completing assignment. So you need to see that you don't introduce new problems. Knowledge-based is theories, principles that you use. You don't need to create a bicycle. You can use whatever you can find is useful for you. And there is a research process. And basically the idea is that you freely start in any quadrant and field, move to another. You can start with knowledge problem and knowledge base. Then you can try something, then you get stuck. You can go back and extend your knowledge base, or you can start to creating some solution, and then you need to check if it's a new one or it's already exists. If something exists, how much you differs, because if it's real science, you should be unique in some aspects. You don't need to be fully unique. Otherwise, it's accepted practice and it's nothing new. You're not creating a new world. So it's quite useful, and we recommend that you feel it during the project. And you can start where you want, but you need to feel it to the end, at the end of the project. And if we compare these two tools, you don't need to discard this. And sometimes people use it and use it successfully, this sequence. But the problem with this picture, as I see it, is it's a bit misleading. It put you on a specific way of thinking how you do it, and it might not be the one you need in your particular case. So you may need to start something here and then get generic things later. So I prefer this kind of things to in this specific case, and considering my own practice. Okay, and to add to this one, as I described, sometimes you are working on implementation first and then on generic artifacts later. So I created implementation canvas, which in a way is a copy of generic canvas, but there is something is different. So you need to have described business case, and it should be a kind of practice that you describe in Canvas. So it should be an instantiation of this practice. You can define specific problems here, and then you need to define how your artifact looks like in this particular practice, because it will be more specific. If you have some methods here, it will be implementation of it. So you need to feel much more here. And instead of research plan, you need to have implementation plan, and you evaluate on this example. So you won't be able to do everything in practice in the project, but you need to think, at least plan how you will evaluate. Okay, you installed your solution in local practice. How do you know that it works and works well? So whom you want to interview, or you want to read system logs if it's a system and analyze them, or you want to have a survey through the customers and so on. And here is effects discovered, and it can be both positive and side effects. And here you can do it in the project, but it's more like you can write down potential possible effects here. And basically what you can do, you can work with these two in alternation. So you can even start here, because you have a business case. You can start feeling this part, and then trying to generalize by reading a literature and seeing which solution exists, or whether this problem can be applied. When you generalize, you can generalize on different levels. For example, this is, you can say, okay, we have a case of alternative medicine or health care, where you can say this is specific company on dietitian side. But it's like the solution here should be more than a solution for just harmony inside to be design science. So this is what we suggest for the project. Good tools. This is Canvas. Canvas is also a good tool. Basically, Canvas is one page, so you cannot put everything inside. It will be just a summary, and the rest will go in the report as different section. For example, artifact can be quite complex, and you need to describe it in a specific section. I think I came to the end. So I hope I gave you some impression about activities and processes in design science. So I need to try to get back to, so I'm stopping sharing. Okay, now questions.
I have one question.
Yes.
Concerning this squared model with improvement, routine, design, exactation, and invention.
Yeah.
It's about invention. The others you have, you're searching for the solution of something, of a problem. Yeah. But in invention, you don't have a solution. You're not searching for a solution. But I see the search for a problem solution as some kind of a goal. And in invention, you also have to have some kind of a goal. You can't just start doing anything to hope it will result in something. So the problem, you might have a problem or a goal or something that drives you and directs you.
Yes, that's true. But what I want to say is that you need to have open mind. So when you started to get to something, maybe this something is greater than what you wanted to use it for. So great inventions and even discoveries, they are often
there's something driving those great inventions.
Yes.
There is somewhere a problem or whatever you would call it.
Yeah, you start somewhere. For me personally, it's difficult to not start somewhere. There is a point where you start, but where you come to at the end can be completely different. Yes. But you need to start the process. Yes. At least for it's how it works for me. You need to start with some goal in your head. For me, it's very difficult to have an abstract goal. So normally it's something that I have right now, or I have something in my past experience.
Yeah. You have to have something to aim at.
Yeah. Yes. Something, even some concrete case where I need to. Which I couldn't solve in the past, for example. Yes. It could be an initial, not an actual case, but something that I was not successful. Yes, for me, it's difficult not to have any connection to real world. But it doesn't mean that it's not impossible to do otherwise. But for example, I can't work from just taking the literature and trying to find the problem defined there. If I have no connection to this problem, I wouldn't try to solve it. So I need to have something in my past or present to start with. But again, it's not a rule. Some people can do it on an abstract level. So that's. But basically, the course is aimed that you can do some design science work in your master thesis, and it's a way of preparing for this. And it doesn't mean that you need to do everything even in master thesis up to evaluating your artifact. You may be just basically defining very well define a problem and some ideas how to solve it, because defining or understanding the problem can be quite a task on its own. But you do it in connection in a practical case, so the problem is real and generalizable. So you need to look at the literature at least to somehow understand that the problem is generic.
There is a chat question.
Yeah. Yes. Basically, you have two canvases, as I said. You need to think about generic solution, and you need to think about implementation in the Harmony Insight case. But this is a mirror in a way. Okay. Any other questions? No? Okay. Then it's time to stop for the moment. So I hope you will come to tomorrow, right? And these questions, have a look on the site, have a look on assignment, start thinking about which one you want to do, and come to the meeting, and I will try to answer your questions. Okay, then if nothing else, okay, then see you tomorrow, and bye-bye, and I hope now I can get this session recorded. Okay.
Bye-bye.
Thank you.
Thank
Thank you.
Bye-bye.
Okay, goodbye.
Bye.
Bye.